Hey guys, welcome to this topic's video where I'm just going to show you how to make a problem like this come alive with GeoGebra and make our options of the correct answer here hopefully make more sense no matter what our quadrilateral looks like, assuming that we meet the satisfied conditions here. So all it says is that this quadrilateral is inscribed in circle O, and angle C is a right angle, as shown above. Segment AB is not parallel to segment DC. Which of these following are true? So, is angle A congruent to angle B? Is angle B congruent to angle D? Is AC, the diagonal AC, is it the diameter of the circle? Or is BD the diameter? And you can see it in the picture, but to help make more visual sense of this problem, which then could get us to the point that if you have an inscribed 90-degree angle, then this diameter BD must be a diameter. Can kind of make sense, I think. So in this case, let's actually construct this picture with the given criteria. So the main thing here is that we have a quadrilateral, it's inscribed in a circle, one of these angles is a 90-degree angle, and what must be true. So in GeoGebra, just grab your circle tool, put a center. If we want these to be the same label, you can just double click a point. Actually, I'm going to rename it. So if you right click the point, you can go to rename. I'm going to call this capital O. Okay, so now we have A, B, C. We need to make this angle C a 90-degree angle. Okay, so to do that, all you really have to do is, if you want to visualize part of the angle, use your segment tool. So here's one of the sides of our quadrilateral. Here's our other side, AB. So to make this a 90-degree angle, all you're going to do is in your angle toolbox here, we're going to hit the little drop arrow, and we're going to grab the angle with given size tool. So I'm going to click on a point that's on the side of my angle first, so it's B. The second point is going to be the vertex. So we're actually, since I clicked on C second, this is now the vertex. It's just going to take B and rotate it whatever angle we want. So I'm going to rotate this 90 degrees. Try to keep that degree symbol in there. And if you think about it, B needs to rotate this direction, which would be clockwise around point C. So I'm going to click clockwise. There's my 90-degree angle. And there's my point B just rotated. So now to get where this point D needs to be on the circle, I'm just going to grab my ray tool. So it's in our line toolbox. Grab the ray tool. I'm going to start my ray at point C and have it go through B prime, which is at a 90-degree angle from B. So now this intersection point is really what I want. So I'm going to click on that intersection, make sure your ray and your circle are both highlighted, and put point D there. And then I can grab my segment tool, and I can finish off my quad. So I'm going to hide this ray, so I'm going to put a segment where the ray is, so that when I hide the ray, we have our side. So you can either hide by right-clicking the object in your graphics window and clicking Show Object. An easier way is to identify the ray section here, and these green circles next to your objects is a hide show button. So if I want to hide something, I just have to click that little green circle and it will hide that ray, and this point B prime needs to hide as well. So there's our picture, and it meets our criteria. We have an inscribed quadrilateral, one angle is 90 degrees. So now what's always true? Well, is A and B going to be the same no matter what? And we can, as we move this around, we can see that that's not true. You can even use your angle tool and measure these angles. The other two questions have to do with diagonals, so let's draw in diagonal BD. Notice that goes through the center, which is the diameter. And no matter what we do with our points, we can see that BD is always going to be the diameter of this quadrilateral with the given conditions. And we can go into some talk about inscribed angles equaling an arc here that's double the angle measure and whatnot. Okay, but just an illustration of how we can meet or satisfy given criteria and then make conclusions based off of that, and how GeoGebra allows us to see multiple examples in no time. All right, thanks guys.